Okay, today we are going to be looking at section 8.8, which is the strengths and lengths of covalent bonds. The main idea of this section revolves around the idea that the stability of a molecule is related to the strengths of its covalent bonds. And basically this means the whole makeup, like the stability and bond length and enthalpy of a molecule all depends on how many bonds there are between two elements, whether it's one, two, or three, or four maybe. But it depending on how many bonds there are, the stability is affected for the molecule. And the stability also varies between elements, like it'll be different between two carbons than it is for two nitrogens, but the main idea is about the number of bonds, which is shown really well in this graph, which looks at bond strength versus bond length. Bond length, yeah. And right here we have a nitrogen that is connected by 3 bonds, and so the 3 bonds between the nitrogens, the triple bond has the shortest bond length, and this is because in a triple bond, the 3 bonds combined will pull the nitrogens closer to each other, and this will because they're stronger, and this will cause the bond's length to be shorter in triple bonds than in double or single bonds. And going along with this, the bond enthalpy is also the highest, meaning the energy released when this bond is broken is the most. And this is because the triple bond is the strongest bond, and it is the hardest to break. So if you do break this bond, then it will release the most energy. Going down to the double bond has a longer bond length than the triple bond because it is not as strong because there's only 2. So the bond length is longer than the triple, and the enthalpy is lower. And then with the single bond, it is the weakest of them all, so the bond length is the farthest apart, and the enthalpy is the lowest because it's the easiest to break, because it's the least stable. And then, so this idea can be followed through in all different elements, and so just remember the difference between triple, double, and single bonds. And some easy questions to help with this are, which bonds are closer together? 2 carbons connected by a single bond or carbons connected by a double bond? The answer is carbons connected by a double bond. This is because this bond is stronger than the single bond, so it will pull the carbons closer together. And then next, which bonds are more stable? Carbons connected by a single bond or by a double bond? Once again, it's by the double bond, and this is because the double bond is stronger, so it's harder to break apart than the single bond, meaning it's more stable. Next is a more complex question that may be asked about this topic, which incorporates, you should have seen this question before about the bond enthalpies, and so this kind of incorporates the concepts into it, but you already should know how to do the math. It's just helpful to look at it again. So using average bond enthalpies, estimate the change in change in enthalpy for the formation of gaseous phosgene from carbon monoxide gas and chlorine gas. And so for this, you want to remember to do the bonds broken minus the bonds formed. So you're going to take the bonds in the first half of the equation, or the reactants, and you're going to add the enthalpies together, and then you're going to subtract the sum of the products together. And here I gave you the equation. So these are connected by a triple bond, the carbon and oxygen, and then the chlorines are just connected by a single bond. And then over here, the bonds are different, so that's how you can calculate it, and you want to use the enthalpy chart. So if you want to pause the video and do that really quick, what you think it will be. Remember, bonds broken minus the bonds formed over here. And you add up these values, and then, so just pause that and then unpause for the answer. Oh. Okay, pause that. Okay, so this is going to be the answer, which is negative 141 kilojoules. And you get this by adding up the triple bond between the carbon and oxygen, and then the single bond between the carbon and the chlorines, which is going to be 1072 plus 242. You're going to have that sum. And then you're going to subtract the double bond between oxygen and carbon, which is 799. It's easy to keep these separate with parentheses because the negative can get confusing. Just simple math. So in parentheses, you're going to have the carbon and oxygen double bond and 2 carbon chlorine bonds, which is 328. So yeah, sometimes you could just get the wrong answer because of a math error, so it's very important to keep the parentheses or do it separately. And you should get negative 141 kilojoules. And because this number is negative, that means the reaction is exothermic, meaning it's letting out heat. So if you have a negative bond enthalpy, then you're letting off heat. It's an exothermic reaction. But if this is positive, then it's going to be an endothermic reaction. Normally it's exothermic. Normally this is negative. But just remember that because that's also going to be a part of your answer, that you don't want to miss that one simple point for just memorizing that. And a way that makes these problems easier is if, I don't have an example of this, but if you have the same bonds on this side and on this side, then you can cross them out and you don't have to put them in your equation. For example, just if you have I don't even know, if you just had a single bond between 2 chlorines on this side and on this side, then you can cross them out because the numbers are going to cancel out in your equation anyways, and you don't want to confuse your equation more. So you don't have to do the bonds broken minus bonds formed. You don't have to do all of them if there are repeats. Just make sure to cross them out clearly so you don't confuse yourself, because it can make the problems much easier. And that's how you can solve the questions from Section 8. It's pretty straightforward, and that's it.